Hi, welcome to our topic for this session. I will explain to you the concept of object-oriented programming, particularly what are these classes and object all about, and the four pillars of object-oriented programming. Furthermore, the object-oriented programming can design and build applications such as a real-time system, simulation and modeling, object-oriented databases, hypertext, hypermedia, artificial intelligence, expert system, computer-aided design, and the like. To start with, let's first understand why we need to implement a OOP concept. First and foremost is simplicity. Why the complexity is reduced and the program structure is very clear. Next is modularity. Modularity, you can decompose your application into modules which they have a separated functionalities. And the last one is reusability. So actually this is very effective in large scale projects where you can reuse the objects to other related projects that you can create in the future. And since we are talking about object is a component of a program that contains properties or what we call data and methods or what we call the behavior. For example, in this diagram, the person is an object and a person has data members or what we call our variables such as the name, the gender, and the height. And we have also the methods here so or what we called our function that a person can walk, can talk, and can run. These are the composition of a class. These are the data members, and these are the methods. In fact, the class is defined as a blueprint or set of instructions to define and build a specific type of object. For the proper implementation of the class, you have to name your class. In this example, we have name our class person. Then our class have its data members. We need to specify the data type and the functions. Remember, you can't create your object without a class. On the other hand, the object will be created in the main method of the program. So in this example, our class person is now an object with the name obj, and this name will be used to access the member of the function declared in our class. Also, one of the important elements in object-oriented programming is the access specifier, where a certain rules is observed to successfully access the data members and the member function of our class. Like for example, we have three specifiers here, which you can use in accessing your data members and member function. If you are using a private access specifier, you can access those data members and member function within the same class, but not in the derived class and also in the outside of the class. For using a protected specifier, you can access the data members and the function within the same class. You can also access that in the derived class, but you cannot access that in outside of the class. And the last one, you can access all the rules specified here within the same class, in derived class, or outside the class. Since you have a glimpse of what is object-oriented all about, now let's proceed our discussion the four pillars of object-oriented programming, and these are the inheritance, encapsulation, abstraction, and polymorphism. Okay, let's further discuss each pillar. We are starting with the encapsulation. The concept of encapsulation is grouping of information. For example, a capsule contains a certain components works together to address a particular pain. And for you to make it easy to understand, when this encapsulation is implemented in a program, actually it is a binding of the private data and public method or functions So therefore, you have to make that the object keeps state private inside the class, meaning that the other object can't directly access to this data or state, but they can call the public functions. So like for example, we have a cat class here, which composed of our data members, mode, hungry, and energy, set as a private access specifier, also with the meow method. And we have also the public methods here, the sleep, the play, and the feed. As you can see, the meow here is invoke, but what's the difference of this one? This particular methods can be accessed by the other classes, but they cannot access directly, modify the private fields. Okay, the next pillar is abstraction. Actually, abstraction is an extension of encapsulation, and this is a very powerful concept in OOP. It typically hides the unnecessary information and only display of what is needed. Applying the abstraction means that each object should only expose a high-level mechanism, so this mechanism should hide internal implementation details. It should only reveal operations relevant for the other object. In this example, if you are using a phone, typically you can only view some features like home button, volume button, and charge input, for example. So the other details of the implementation of this are hidden from the user. Okay, the third pillar of the object-oriented programming is inheritance. Actually, there are different approaches of inheritance, and these are single inheritance, multi-level inheritance, multiple inheritance, hierarchical inheritance, and hybrid inheritance. But generally, the concept of inheritance is there is a common logic set in the parent class and can be implemented differently in a child class or a derived class. Like for example, this diagram show to you the inheritance structure. As you can see, we have set here the parent class, the name is person, and the child classes. We have teacher, the students, the private teachers, and the public teachers. So this particular data members can be inherited by this teacher class and the student class. And same with this private teacher child class can also inherit what is in the teacher attributes. And same with the public teachers. As you can see, all of these child classes have their additional field. So therefore, these child classes take all the private fields and methods from the parent class. And the last pillar is polymorphism. So polymorphism means you may reuse the methods and implement in a child class differently. Actually, when you implement a polymorphism, you have this method with the same name, but it will be implemented differently. Like for example, in this diagram, we have here our class circle, and the methods are the calculate surface and the calculate perimeter. This particular method must be implemented in this particular class triangle and rectangle. But these particular classes have incorporated a particular computation to make a triangle, and the other one the rectangle, so you can add some variables or whatever requirements for you to produce a rectangle. So this is a polymorphism example. Okay, that's all. Thank you for watching and listening to the topic. I hope that you have learned something in this session. Keep on watching and see you in our next topic.